What's going on, guys? It's the Unhinged Engineer here. Today, I actually have a remake of a very old video. It's the third video I ever made, and that was a discussion of how I broke into artificial intelligence from aerospace engineering. I was working at a machine learning research institute at a top university doing AI research. We'll discuss the specifics of what that research was about shortly, but I was doing research in that area despite having never taken a class in AI, in machine learning, in GPU programming, which was a large component of what I did. I didn't have a formal background in artificial intelligence. Instead, I had one in aerospace engineering. So I made a video breaking down how other aerospace engineers can actually break into this, as I'm sure you're well aware, very booming field. My production quality was not as good back in the day, and so I thought I'd revisit this topic with a bit more rigor and hopefully share with you guys some actionable advice you can use if you're trying to break into AI from aerospace engineering. So, like I said, I'm the Unhinged Engineer. I make professional development content for other young engineers like myself, and if that's something you're interested in, this is the channel for you. First, I'm going to talk about my story in particular before we get into any practical advice. Starting off with my academic story, I figured I'd just go through all of my education first and then through all of my professional experience. And once we've gone through all of that, we're going to get into advice. The first portion will be mostly technical, talking about what's the actual technical engineering background I had from aerospace engineering that I applied to AI, and then we'll get into some of the more practical stuff about how you can make this transition, what you should focus in, what were some of the things I struggled with, and some of the strengths that I tried to play to along the way. So starting off with my story, let's break down my academic history with regard to AI. I'm actually going to start all the way back in high school just to say that I really hated coding in high school. I took an awful AP computer science class and never wanted to program again. So I knew I still liked math and science and wanted to do engineering, but I never wanted to do coding. So I came into college as a mechanical engineer, actually. During my freshman year, the main two things that were important to the story are, one, I switched from mechanical to aerospace. The courses in aerospace engineering were much more interesting to me than those in mechanical. So I switched to aerospace. That's the first thing that mattered. And the second was that I had really strong calculus and linear algebra professors. So I took Calc 1 and Calc 2. I actually took more advanced versions of the class because A, I'd done some calculus in high school, and B, these courses were specifically geared towards engineers. So I took those, had a good linear algebra professor as well. I still think linear algebra is the most underrated area of math for engineers because it's just emphasized so much less than calculus, but nonetheless, I started to realize I enjoyed these courses, and that kind of would influence what I did later. In my sophomore year, this was where things started to ramp up. So I took differential equations, focusing on both ordinary differential equations and partial differential equations, as well as vector calculus, which was kind of this hybrid of the advanced calc courses I took and linear algebra. More advanced math, obviously going to be relevant to machine learning. The other thing was I started to come back around to coding. So my intro to programming class used C++, which is a bit odd because usually people learn the foundations of computer programming with an easier language like Python, but I actually really enjoyed learning in C++ and kind of having to learn the fundamentals myself in a more difficult language. That was the dedicated course I took, but also in a lot of these other math courses started to use MATLAB more and more. So I realized at that point, maybe this coding thing isn't so bad. I also knew obviously the financial benefits of learning to code and working in the more computer-oriented aspects of our field. And so I started to warm up to coding a little bit, which would really start to matter in my junior year. So junior year is really where we got slammed with the advanced aerospace coursework. So this is where I took aerospace structures, aerodynamics, orbital mechanics, and the biggest two I think are relevant to this were Intro to Control Systems, which control and then more broadly guidance, navigation, and control is the main focus area I would take in my courses and research, but also numerical methods and aerospace analysis. So stuff like Fourier transform, stuff like Runge-Kutta methods for numerical approximation, all that fun, super advanced math was heavily stressed this year and required us to program it in MATLAB. In addition to all that coding in MATLAB, I also did more programming coursework in C++, kind of more flight software / simulation oriented courses. More hammering in the aerospace concepts alongside more advanced programming, getting into GNC. This is kind of where the momentum really started to gain. Last but not least, senior year. I specialized in autonomous vehicles. Now that had a capstone component that, to be honest, was kind of crappy. What really hammered a lot of the advanced concepts home was this elective course I took alongside that capstone. This is where we really got into decision-making models, advanced perception technologies like different sensors, fusing measurements, using filtering and other types of algorithms to actually understand where we are. and some of the more autonomy coded aspects of GNC, this course was what really emphasized those. So this is in general my academic story. Now I want to talk about my professional story. Going back to my junior year, I actually had an internship that focused on autonomous satellite piloting with reinforcement learning. So given what I just said, you could imagine how this started to steer me towards the field of autonomy and AI. We were using deep learning and reinforcement learning techniques to kind of figure out trajectory generation for different types of satellite maneuvers and missions. So this was a super cool project because it combined a lot of the programming and aerospace experience I was getting in school, but also forced me to learn a lot about deep learning on the job. So I didn't actually really know what a neural network was when I did this internship, and I had to learn a lot of it on the job, in addition to all the fancy optimization techniques used in RL, which we'll discuss in the technical section. Learned a ton of deep learning on this job, and it was really the first time I understood that you could fuse AI and machine learning with traditional aerospace, specifically GNC, modeling, simulation, numerical methods, stuff like that. This was the first time I really saw that fusion in action, and at that point I was hooked, which you could probably tell from when I did my senior year. That's the reason I decided to focus on this. I had 2 internships during my senior year. The first one was remote during the semester. It was actually as a software developer at the Machine Learning Research Institute. I wound up working after school. I'm gonna leave this pretty light for now because we'll discuss it in depth in a moment. But in addition to that, I interned as a guidance, navigation, and control engineer after I graduated. So by the time I post this, I will probably have made a video going into this internship in depth. Stay tuned for that. And that was really cool, but it was very, very purely aerospace, like no real artificial intelligence component to it. It just stressed a lot of my GNC skills to the maximum degree. Let's talk about my first job out of college, which is basically just an extension, the full-time equivalent of that first internship I did. I forgot to mention, I almost took an autonomy engineering job at a different research institute, which would have had to do with submarines and torpedoes, stuff like that. But I wound up going back to the place I interned at because it was really, really cool stuff, and I liked the people I worked with. At this research institute, I was a software engineer working on the performance optimizations of different ML applications on GPUs. So that's a bit of a mouthful. Effectively, there were computer vision and EW, or electronic warfare, applications that we were trying to improve the performance of either on GPUs or other types of processors like ASICs, FPGAs, stuff like that. This was a very purely software engineer role. It was much more low level than I'd ever done before. So embedded software development is like the highest level of abstraction you get to work at in C++. But I spent most of my time doing stuff like Verilog, looking at HLS that was generated, all sorts of embedded software development, either on GPUs, so like CUDA kernels, or the things I just mentioned on FPGAs. So a lot of low-level programming, which I really didn't have a ton of experience in, but I like to think I picked up pretty quickly with all the coding experience I did have in C++. This was not really an aerospace role at all. It was very, very purely AI/ML, and I liked it. I learned a ton of stuff. I learned about digital signal processing and electronic warfare, which is not really something I touched on directly in aerospace engineering. As I'll mention in the technical overlap section, I was able to apply a lot of the skills I had from GNC to this, but I never really took a DSP class, and certainly not an EW one. So I learned a ton on this job. The people I worked with were a blast. And I had this job for 2 years before largely returning to aerospace. And considering this was an ML dedicated research institute at a top university, and I held this job as a full-timer for a couple years, this is really what I consider my break-in. So I'm proud to say I worked as a software engineer in AI research for 2 years, and this was my break into AI I'm referring to in this video. Like I said, I wound up going back to aerospace after this because I did miss my roots, but really, really enjoyed that job and still use a lot of my AI skills I got during it extensively in my current work. Love this role. Definitely was proud to break into AI, especially around like 2023, 24, just after the ChatGPT release. And so it was an exciting time to be in AI, as it still is today. That was a lot of narrative stuff. Let's talk about technical overlap between aerospace engineering and AI/ML. The biggest one is obviously going to be math. It shouldn't be a surprise to anybody. Both leverage calculus incredibly extensively. Differential equations for modeling in aerospace and for lots of model training and optimization systems in machine learning. Linear algebra as well. Like everything's a vector in aerospace engineering. That's largely about dynamics, or if you're doing structural engineering, FEA representation of different assemblies. In AI/ML, just about all your models are represented by matrices and vectors in some way. Anything from a neural network to a support vector machine, it's going to be written out as vectors and matrices, and so you're going to have to know how to manipulate them. So those shared mathematical foundations are really, really important to both. And so if you get a really strong grasp of these in the beginning, that's what I mentioned about the early freshman year courses. If you get a really strong grasp of these in the beginning, it's going to pay dividends throughout your career in either one or both. The biggest area of overlap, in my very biased opinion, is guidance, navigation, and control. Each of its components use specific forms of advanced math that are very, very relevant to ML. And so as a GNC person, I think it put me in the best position to transition to AI ML. Since then, I've kind of shifted more into modeling and simulation, which I really enjoy. But at the time in my education, I focused largely on GNC, most strongly in the C part, but nonetheless, GNC really put me in a good position to transition. And so if this is an area that you might want to transition to and you're thinking of what you want to study in aerospace in the meantime, GNC is a great option. Also a great option for transitioning to robotics, side tangent. Guidance is really about optimization methods, and a lot of these optimizers are running on graph representations of a space or of different possible solutions. Graph representations and running optimizers on them are a huge part of guidance. And so understanding that is really applicable to machine learning for obvious reasons. Again, neural networks are largely call graphs, and so being able to understand those different optimization methods and how they're used in training there. In guidance, they're used for actual raw optimization. In training, you're optimizing a reward function that you've set up to represent whatever human intelligence you're trying to replicate. Guidance is a really close analog in that way. Navigation is really going to be your bread and butter for probability and statistics, understanding how to actually model and drive stochastic systems. So whether that's the underlying math there or kind of the more rigorous robustness testing methods like model conversion. You want a Kalman filter to converge so you understand where your estimate's actually pointing you to. In the same way you want a model to converge so you know it's actually behaving in a way and the weights are largely stable. Last one, controls, which is kind of my baby, all about eigenvalues. So for stability analysis in the controls case, and also understanding kind of different factorization methods that are used in machine learning, they all center around eigenvalues. And then more on the coding front, dynamic programming is a huge part. I have the Bellman equation listed there, which is a big part of reinforcement learning, but dynamic programming is also a huge part of different control systems that are commonly used, especially optimal control systems. The point I'm trying to get at is aerospace writ large has really highly shared mathematical foundations with AI/ML. And if you're picking an advanced area that you're trying to specialize in that is in particular best poised to transition to AI/ML or robotics, I would highly advise you check out guidance, navigation, and control, as I've kind of talked about at length on this channel. Now I want to talk about some practical advice I have from my experiences that could hopefully help someone else get into AI from GNC or other fields of aerospace. First one I want to talk about are my weaknesses. I had two major ones coming to AI/ML from aerospace. The first one's actually probability and statistics. So of all the different kinds of math, I think we really strongly emphasized calculus. Linear algebra was less emphasized, which I didn't like, but we got the basics in and used it so much that ultimately you kind of got it through osmosis that way. I never actually took a probability and statistics class. I think it was an option for one of my electives that I didn't elect to take. So I had never done a formal class in probability and statistics, and that really matters for AI/ML. I would advise, if not taking a class specifically in probability and statistics, at least getting an interest in it, reading some books. I think that's kind of the area of math that is the biggest gap in aerospace engineer skill sets when transitioning to AI/ML. It's not enough to just know what a mean and standard deviation is. I think in my hubris as a young engineering student, I thought, oh, I know what a bell curve or a Gaussian distribution looks like. It's got a mean and a standard deviation. Like, that's not enough. There's a lot more to probability and statistics than that, especially when you look at stuff like Bayesian inference, which is a huge part of AI/ML. Yeah, it gets more complicated than just that. So I would highly advise some additional work in it, or a class if you can manage. The other one is coding. I was an aerospace engineer making a strong effort to learn to code, to sharpen my programming skills. But the reality is when you're entering into the AI/ML talent pool, the standards are just higher. Like, the standards for good software engineering practices and understanding of how to actually use the tools is just higher in AI/ML fields than it is in aerospace. And a large part of that's because even though aerospace had a lot of coding components to the classes, those tricks of the trade, right? The craft of coding. I'm thinking of it more as a trade versus a knowledge area, right? I'm not talking about data structures and algorithms and knowing what a linked list is. I actually didn't really take a DSA course, but that hasn't affected me as much as the fact that when I was in school and my friends who were doing pure computer science projects and internships were getting those foundational skills of actually being a software engineer, not just computer science, I was not. I was taking coding and I was applying it to aerospace problems. And the biggest example of this I could think of is most of the homework projects I did were one file, just one file, like a MATLAB script or a C++ script you would compile in some way. Maybe a large project got to be like 3 or 5. That's very different from working in a large repo with multiple contributors and several different versions and branches and stuff like that. So the actual foundational skills of software engineering that I do talk about on this channel were a big gap for me, and I would highly advise investing some time in that. Quick side note here, I did actually never take Python, like take a Python class or learn it in school. To be honest, I don't consider this a big weakness because Python is just so freaking easy. It does get harder as you get into frameworks like PyTorch, but Python is really quick to pick up and I had no problem. Now there are some advanced features of Python that I hadn't heard of and didn't have experience with, but even those you can pick up pretty quickly if you understand how to write things in more cumbersome, we'll call them cumbersome languages like MATLAB and C++. The biggest strength I think I had going into AI/ML from aerospace is using my first principles thinking skills. So computer science, as I understand from all of my friends who studied it explicitly, CS is a very detail-oriented field. Aerospace is much more broad and teaches you a little bit about a lot of things. And so you learn to break complex systems down into their fundamental components and kind of treat each one as a black box. Now, there are lots of CS majors who understand the details of all these AI models much better than I do, but even as somebody operating at the detail level, like writing very low-level CUDA code, even as somebody operating that far down the stack, it was a very helpful skill to actually think about it from first principles and compartmentalize things accordingly. Last piece of advice I'll talk about here is actually to dive into the classical machine learning a bit more before going straight to deep learning. And there's two main reasons I would advise this. For one, without learning the foundational types of models, it's easy to miss gaps in that first principles understanding I just referenced. So to really understand something as intractable as a neural network, it's good to understand the more tractable model types like SVMs or even something as basic as linear regression. Good to get a foundation in those simpler models that you can understand better as a human, and then translate those principles to something that's less understandable like a neural network. The other piece is actually for going back to aerospace engineering, if that's something you're interested in. Because of the different interpretability and reliability requirements in aerospace, it's very hard to deploy just a raw neural network that you don't have any insight into in an aerospace system. More likely than not, you're going to be using a classical ML type model like a state machine or a decision tree or something like that. So actually really understanding the math of these different models is not only helpful to transitioning to AI/ML for the reasons I just described, but also in aerospace. And so if you're trying to amass experience in aerospace that you can then use to translate to a more AI focused firm, you can do that through classical machine learning, which is still really, really important, very important in the modern field of AI/ML. People think everything's a neural network because LLMs are getting all the buzz for understandable reasons, but I still think that classical ML algorithms serve a very strong function in the larger ecosystem. This is all my practical advice for somebody transitioning to AI from aerospace engineering. I will say, to wrap this video, my story is actually not that rare. I thought I was a special snowflake when I was doing this and I was the only one, but going to AI, I met a lot of people from aerospace, especially with similar backgrounds to me, like in guidance, navigation, and control. Just a lot of the skills and a lot of things that are emphasized translate really strongly for some of the technical ways I mentioned, as well as the more intangible ways I just referenced with first principles thinking. And so I think that it's definitely something that can be done. I'm not the only piece of proof. There are lots of other ones out there. And if it's something you're serious about pursuing, then I hope this advice was helpful and I wish you best of luck. Like I said, I'm the Unhinged Engineer. I'm an aerospace engineer by trade, and I make professional development content for other engineers like myself. If that's something you're interested in, this is a channel for you. Thank you so much for watching, and I will see you next time.